Good morning, everyone. I'm Nagashri, and I'll be presenting a case study on greenhouse control systems. So, coming to agenda, these will be the topics that will be covered in the presentation. So, introduction. A greenhouse is a specially designed structure with plastic or glass roofs that provide a controlled and protected environment for the growth of crops and plants. These structures they help in shielding the crops from extreme harsh external weather conditions while creating a favorable climate for plant development. The climatological conditions inside a greenhouse, such as temperature, humidity, soil moisture, light intensity, and carbon dioxide levels, can be continuously monitored and controlled to ensure optimal plant growth. Various sensors they used to measure these parameters and they're being monitored continuously. So based on the sensor inputs, there are few actuator devices that act based on these inputs. With the advancement of technology, IoT based greenhouse control systems they play a vital role in modern agriculture by enabling automation, remote monitoring, and real time decision making, which will improve the productivity, crop productivity, resource utilization, and operational efficiency. The data collected from different sensors, it's being stored on centralized servers, database or cloud platforms wherein it is analyzed and also monitored to devise or optimize control strategies required for the enhancing the efficiency. This analysis it also helps in correlating the crop productivity with the different environmental conditions, leading to the better planning and strategical planning of the management of the crops. Furthermore, the system it makes use of a wireless sensor networks to monitor and control the agricultural parameters within the real time. It ensures better management, maintenance, and sustainability of agricultural production. So, this is an example of the greenhouse system wherein you can see the plants they're being placed inside a glass house wherein you have the sensors which are being attached indoor and outdoor based on the crop, and then these collect the information like the temperature, humidity, water content, and the light intensity. And there's a remote management and there is equipment control. So here the equipment control it relates to the irrigation control, the heating controls, and the light controls for the system. And then the remote management it involves the user connecting things, that is the smartphone, the web portal, the scheduling, historical data, and etc. Coming to the components of the greenhouse control system, first we have the sensors. So they are used to measure the environmental parameters within the greenhouse system in real time. Temperature sensor, it measures whether the internal temperature is optimal for the growth of the plant. Humidity sensor, it monitors the air moisture levels and it will prevent the plant getting any stress or any disease. Then soil moisture sensor it will detect the water content in the soil, whether to provide irrigation or it can be or may not. Then light intensity sensor, that is the LDR light sensor, it measures the amount of light available for the photosynthesis activity. Controller or the processing unit. So here the controller is the brain of the system, which will which will control the overall activities of the system. The examples are the microcontroller, which is the ESP32 or the Arduino chip, and the single board computer Raspberry Pi. So the functionalities of the controller are it will receive the sensor data, plan the future actions, comparing the readings with the predefined threshold values. It will send the control signals to the actuators and communicates with the servers and the cloud platforms. Then actuators. So these are the devices that act on the controlled environmental conditions based on the sensor inputs. So they act if the sensor inputs they do not perform better. So you have the fan. Like if the temperature is high, they turn on to control the temperature, and the water pump it maintains the soil moisture. Heater it increases the temperature during the cold conditions. Artificial lights it provides required light intensity if there is a decrease in it. And ventilation system it controls the humidity and the CO2 levels throughout the system. Database cloud storage. So the main purpose of the database is the storage. It stores the sensor data which is needed for the analysis and monitoring. It stores the historical, that is the previously maintained data, as well as the current real time data. It helps in the performance analysis and optimization. The examples of the database is the cloud servers, local databases like the SQLite and the Postgres SQL. Then coming to the software platform, so these platforms they're responsible for the communication, controlling the system logic, and the user interaction. So we have backend software. It maintains the data processing, decision making algorithms, and the automation rules. So REST API, it is a communication interface between the hardware and the applications. And the web and the mobile application, it will display the sensor data to the users and also allows for the remote control over the actuator devices, fans, heaters, etc. User interface, this is the communication between the this allows the users to monitor and controlling the greenhouse. These the examples for the user interface are the web dashboard, the mobile application, admin panels for the data management. Then, so Python program. So from now we'll be covering the code part. So coming to the coding, so you have from django.db import model. So here we are from the Django database, we're importing the models. So we're using the models to store the sensor data values. That is so here the temperature, the humidity, soil moisture, and light intensity. All these values are being stored into the model greenhouse data. And then it also includes another functionality that is the actuation device status. It is also being recorded into the models. So it the status being on or off, and even the timestamp. That is, it includes the real time data of the actuators and sensors, and also the time when the data was inserted into the data set or the database. Then define safe. So here the main control logic is applied wherein so here for example if the temperature is greater than 30 the fan is made to automatically run, and the same applies to the soil moisture as well. So if the soil moisture falls below 40 the water pump is automatically run and it helps in regaining the soil moisture. And this light intensity, as here it is the condition is less than 500 the light is to be on. Coming to the serializer.py, so from the Django framework, we are importing serializer. So the main function of serializer is to convert the data into the JSON type for the application program interface. Then from the models, we are importing the greenhouse data model. And here the meta is it's used to configure the serializers, and the model used here is greenhouse data. And the fields here, it's all because it's including all the factors we discussed, that is the temperature, humidity, and all those being recorded. So coming to the urls.py, so from the django.urls, we are importing the path, which is you're linking the server to the database. And then you have from the views, we're importing the list of all the values, and the greenhouse is nothing but the app there. The project URLs. So here the Django, it is importing the admin. So here the admin, here it's another control panel which has a different type of functionality. And then django.urls, it imports the path, that is you're defining a URL, and then it will include all the app URLs as well. Then from the django.http, you are importing the HTTP response. That is nothing but, so the HTTP response is you are writing a text response, and then you're defining a home. Now we are creating a home page view wherein we are writing a response, that is the greenhouse control system is running. So when the home page opens, so this statement will be displayed there. Then coming to the admin registration. So here the admin is a control panel wherein a set of greenhouse data value, it's being stored alternatively in the admin side, and here it is being registered and it cannot be altered by anyone. And admin is responsible for the storage as well. So coming to the architectural diagram. First, so the components, as discussed, we here the system, it consists of the sensors, actuators, the controller, the database, the REST API, and the user application. So first, so when the plants are being kept inside the greenhouse, so these sensors, the function is they collect the data like based on the temperature, humidity, and this one. And these readings they're being given to the controller. So the controller, it's the brain of the system. It'll plan all the actions, and now based on the sensor readings, it provides the actuators also run. They run if the sensors are failing to act, and then these two readings they are being provided to the controller. The controller saves, it analyzes them first and then monitors them, then saves it to the database. So the database, it has a record of all the previous and the real-time data and all the analysis and monitoring reports. And then in the REST API, it's nothing but a framework communication interface between the user and the database. And here user, he logs into the server through the mobile or a laptop, and he gains control. He gains access to the control system, learns about it, and knows the actions of each of these. And he also gains knowledge whether the plant is getting the requirements and it's growing efficiently. So now I'll be showing you the working part. So here, this is the project configuration wherein we have the project, the greenhouse, this is the app wherein we have the admin PY. As I told, this is the registering all the values. The apps, the greenhouse is the app. The models wherein you're storing the sensor values, and the actuator status also with the timestamp, and serializer and simulator. This is an extra part wherein this is a different approach wherein we are extracting real world sensor data from the database rather than just adding the values manually. So here greenhouse data, so here simulator.sensor data, we're defining the simulator here. And then we are greenhouse data.objects. So we are creating an object greenhouse data, and the same values they are being extracted, but there are also ranges that are being done, that are being applied where the temperature falls and the humidity, etc. And then the greenhouse project, we have the, now I'll be showing the working. I'll run the server. So this link, it'll open the Chrome. Yeah. Here it shows. So this shows that the greenhouse control system, it's running successfully. And then I'll be opening the admin side. So this is the administration registration site wherein we have the groups and the different users. So currently in the users, there is the admin and the You have the admin and the Nagashri myself. And then in the greenhouse data, there is data being registered here. Now we'll be going to the API. So this is a Django framework when here it is extracting the real world sensor data from the database. So here so consider the I'll be taking the ID3, ID4. So here we have the temperature 34, humidity 47, soil moisture 23, light intensity 878. So here you can see the temperature, it's greater than 30, so the fan is being turned on, and the pump status here it's true because soil moisture it's less than 40, and the status it's false because here it is more. So here there are already 9 entries. I'll be adding one more. So I'll be running the shell. Then I'll be calling the simulator function and then the simulator object. And then we'll be exiting the function. Now we'll go back and we'll check whether it's being added or not. So here the Chrome, it reflects. Now we will see if it reflects or not. API slash. So there were 9 entries. Now see the latest one is the 10th one. So we can see now the temperature, there is a variance in the temperature as well. 54 is the humidity and the fan status, pump status and light status. So this concludes the results, and then we'll be going back to the presentation. So coming to the applications of greenhouse control system. So the commercial crop production. So greenhouse, it's being widely used in the large scale crops farming, which includes the organic vegetables, the fruits and the flowers, by maintaining the controlled temperature, humidity and light conditions throughout the whole year. And then off-season cultivation. So these systems, they enable the farmers to grow off-season crops by providing the artificial climate conditions and the environment which will increase the crop yield and also the availability in the year. Then water and resource optimization. So you have the automatic monitoring of the soil moisture and the climate parameters. They help in the efficient use of waters, fertilizers, and energy, reducing the wastage and the operational costs. High value crop farming. So greenhouse systems, they're used for the farming of sensitive crops and also expensive ones such as the orchids, medicinal plants, and the exotic vegetables that require precise environmental control, research, and agricultural experimentations. Agricultural universities and the research scientists, they also utilize this greenhouse pattern system or method to study a particular plant growth behavior pattern under different controlled climatic conditions. Urban and smart agriculture. So these greenhouse control system, they support different types of farming like the rooftop farming, vertical farming, and smart city agriculture by enabling controlled cultivations in limited spaces. So, coming to the future implementations of greenhouse control systems, so computer vision, by implementing the computer vision for the plant health, it helps in so by using the cameras, it helps us in detecting the diseases or the infections or the insects that are affecting the plant growth status. Mobile application control. So farmers can control the fans, pumps, and also the lights using the smartphones. So renewable energy integration. So They utilize solar power to reduce the electricity by making the system eco-friendly and reliable. Integration with smart farming system. So connecting the greenhouse with the weather forecasting and agriculture management, it helps in making the system more efficient. And then voice and the smart assistant integration. Control greenhouse devices. They use the voice assistants and commands, which will help the system efficiency and the reliability among the different age groups of users. So this concludes the greenhouse control system. So greenhouse control system, it's a different and a modern approach in the field of agriculture, which will help farmers learn better in the agriculture field. Wherein the modern approaches, it will help save the time and also helps in the productivity, efficient and better productivity of crops, wherein we can even grow off-season crops by providing artificial temperature and climatic condition. So this there are methods of growing wide crops through the usage of greenhouse control systems. Thank you.